everybody, Randy Richard in the shop. I'm going to get started on the steam engine build, and this is going to be a multi-part video series. I'll try to do at least one segment a week type of thing. It's going to take me a little while to build all this stuff, I think. Let's take a look at the cylinders. I'm going to start with those and kind of how I'm going to start machining them. Yesterday I spent finding stock to build these engines out of, and I think I came up with just about everything I'll need, and a little bearing bronze, and a little chrome moly, and what else we got here? We got some little few scraps of hex brass we'll need, some 1 inch, or no, it's not 1 inch, it's like 7/8 brass or something, and I got some springs I can use. I got a whole pile of springs in here. And brass nuts. Oh yeah, even some tiny ones, even some 440 brass nuts there. 1032 nuts, I need a few of those. And a few more springs in here just to choose from. Anyway, let's say that's all. I got all the parts thrown in there. No, I'm gonna end up needing that. This is a mandrel. Yeah, so I got most of the parts. I'm just missing a couple screws. I'll come up with those, or I'll make them. Anyway, so the plan is, here's the cylinders. Now, both of these cylinders, this one's brass and this one's aluminum. So these were both made with the same casting. They're relative size-wise, they're very close, or they were made with the same pattern, I should say. So this is really close to a 1/2 inch. I have a 501 reamer. I'm just gonna set them up kind of loose, and the reamer, if these aren't clamped down tight, the reamer will end up just following that hole, so I can get a nice clean hole. They have some corrosion in there and oxidation and stuff, so that way I'll clean up the hole and get it to a consistent size. Then I'll take a gauge pen. Hopefully there can be 501. So here's a 501 gauge pen. And, it does not fit, obviously. And I'll be able to put that gauge pin in the cylinder and indicate on this when I put it in a 4-jaw chuck. So I have this in there in the lathe, and I'll indicate off of the pin, so I have a nice concentric way of dialing in the bore, because it's not really very smooth in there. And even the reamer will make it nicer, but I'm more looking for a consistent hole, not a surface finish with the reamer. So I can have that in there nice, and I'll be able to indicate on it for straightness also. I'll stick it maybe halfway, and then I'll be able to indicate close to the cylinder and far away to make sure we are straight in the chuck. And what we'll do is we're going to face it off, we're going to bore it. So this is square and concentric, and then we'll be able to flip it over and face off the other end. That's the plan, at least. After we get the bore all and the ends squared up, then we'll start dealing with the valving surface and mounting surface features. There's holes to be drilled, there's a recess, and for a mounting of the rod. So we'll have to deal with that. Now, the hole situation, the boring and the facing is the same for both cylinders. That's why I'm just going to do them both at once. But the facing, the mounting fixture feature is the same on both, but the holes and porting is different. So we'll have different setup for those. But I like to get these done. These are individual parts, not really relating to the other ones too much other than holes. And so we can get these all wrapped up, done, set aside, and then we'll continue on with something else. But I thought we'd start with the cylinders. So the approximate size here, roughly right now, these are 1.83 in length. 1/625 is going to be the finished. That's called for the finished length. And let's see here. This is roughly 172 in width. probably end up being more closer to 1 inch in width once we when I clean this. I'm going to clean these sides up probably. We'll see how that goes. I was thinking about cleaning those up because the ends will be clean, and then maybe do these also, so we're a consistent size. And these are about the same. This one's about 30 thousandths less than that. This might have had more shrinkage, you know, but I'm sure they'd use the same pattern for these. And diameter, outside diameter, about 1/356. Okay, and this one's about the same, 1/363. So they're similar, very similar. This one weighs about twice as much as this one. So anyway, I'm going to show you the modeling I've done. We'll show you this engine for now first, and then in a following video we'll get to show you this modeling. I'm not quite finished with the modeling on this one, but we'll show you the modeling on this one here before we get over to the lathe. This is the Gears 2005 engine from the Oregon Home Machinist. That was the group in Oregon that Pat headed up for a number of years, and they had a show of engines, model engines, steam engines, gas engines, you know, all sorts of stuff that home machinists and stuff had made. And they would also offer a kit for that year that they would also sell to raise money for their group. And the show was called Gears. And this is from the Gears 2005 show, or their 2005 model. And I took their drawings and drew and modeled the entire unit here, and you can even make it run right by hand. Now what I'm going to do is I'm going to just kind of show you and go through some of the parts, and you can and we're going to make it run. One thing I'm interested in is, for the viewers, should I go through and show you the modeling of every part in the videos if you'd like, and should I actually show you how I drew these things and modeled them? It'd be, you know, it'd be a lot of videos. There's quite a few parts, but is it something that, you know, you'd be interested in and learning how to do this? I did this, and this is in Fusion 360 now, and I've also used Onshape quite a bit, but you know, they're very similar, and I've used a little bit of SolidWorks. The programs are really very similar in a sense, and you end up with the same kind of product. Now, they do things a little bit differently, and you know, some of their commands and all that. But if you have an idea, once you have an idea, you can use the ideas and use them in all the programs. Well, we'll just go around. So here's the cylinder right here with the red band and the green in the middle, and this part here. That's the cylinder. Then you have the cylinder head on this end, this green one with the G, and then you have the other end, which is the stuffing box or packing gland end. It's held on by 440 socket head cap screws. That's what they have they used, and 4 on the other end, obviously here. The base here this is a casting. The cylinder is a casting. The ends are castings. Flywheel's a casting, and then all the rest are machined parts. These are the ports for the steam or air. That we're going to use air for now, and inlet and exhaust. We have let's see here. We'll go over here. This end is the shaft that allows the cylinder to pivot, and then they have a spring here and a couple nuts and some little caps on the spring as a tension device to hold it tight against the base part here. against this surface right here, this joint. And then you have on this end, of course, you have a flywheel right here, and then a crank over here, and a crank pin. This is like your crank web on a crankshaft. Now they drew a couple designs of this, a round disc, which is very simple to make, and a cutout one. I'm going to do the cutout one on the other engine, and on this one I'll do the disc. That way I'll show both of them. Then of course here, so you can rotate this. Here you have the packing gland nut, and inside there's packing, or yeah, packing. It's called packing. Even on big engines, it's called packing. And there's bronze bushings in here and in here, and right here there's a bronze bushing also. We can zoom in here. They also drew a couple options on the connecting rod. The piston connecting rod here as a one piece. This is a one. I drew this as a one piece one, but they also have an option in their drawing to make this out of two pieces, where the head is one piece and this is screwed into the head, if you don't have the ability to make it as a one piece. Nice little bronze bushing in here. And then you can see here there's a knurl. They did a straight knurl on the end and press fit it in the shaft here. This is your crankshaft, main shaft. It's pressed into the crank web. Now on the flywheel side, this is they used a set screw and machined a flat on here, a set screw. And here's a zoom in feature of this side over here, where the spring is in the center, and then these two little brass caps and a couple lock nuts. And this is just 1032. And then there's a bushing in here and on the other side of it. And then, like I said, in here there's a bushing and a bushing in here. Then they used a couple little plastic discs, Teflon discs, or in here they just said plastic, but Teflon would be nice and slippery. And in here is a spacer, and there's should be one over here, and I have to adjust that maybe. I'm going to make this run actually, which is kind of cool. So this is my rotary joint. All those little blue things I just turned on are joints, and I'm going to select that one joint, and I'm going to animate the model, and then I can just turn off the joints if I want, so you don't see them, and there you go. It's going to run, which is kind of cool. Doing this sort of thing really helps you figure out clearances and such like that. Especially like right here, I realize how much, as the piston rod comes in contact with the packing gland, how close is that? Well, I'm going to have to screw that packing gland in quite a bit, and just have a little bit of clearance on it for it not to hit the head of your connecting rod. So that was something to realize, how much I had to go in. I'm going to make the cylinder transparent here so you can see the piston inside. Here I've made the cylinder transparent, actually about 30% transparency, so you can see the outline and of the cylinder, but you can see the piston action. And another important thing you can see is that this piston, the nut, almost touches the end of the head here. I mean, it's very, very close. It looks like it is touching. And if you turn it really slow, we'll do that, and you'll see it is really touching. Here at the top end, the stuffing box end, I have a lot of clearance still. So this tells me in their design, the separation between the two, from the center of the crankshaft and the pivot point of the cylinder, they actually could be spread apart a little bit to give me a little clearance on the bottom end and use some of that clearance on the top end. So it's a little more even in the stroking of the piston, and not making sure you're not going to have any interferences. Now, the other thing I was looking at on this is the position of the porting. You can see here the circle moving back and forth over these other two holes, and that is the end of the port that's in the cylinder. and it goes from the cylinder on the over here where the cursor is, and then it's at an angle. Over here is the other end of it exiting the cylinder, and you can see how it passes over the porting in the engine base, or the mounting surface for the cylinder. And you can see that there's how the overlap, it almost closes off half of the cylinder, the port, as it comes up. And down, it closes off about half of the port also. But these are things you can notice when you create a model for things, and you can see it's the same problem on the other end, the same situation, because the ports in the block are also at an angle, and they have to be at an angle because of the design of where the ports are. These are the interesting things you can see when you do create a model for something, especially when you're using active joints and drive joints and things like that. It's kind of cool. Here is the cylinder model view, and you can see the internal porting right there, the screw holes, the recess for the mounting of the pivot rod, and mounting screw holes, and the other end of the ports. And this is the other end. Now let's take a look at it through a little bit of invisible mode. So I used 30% there, which is a pretty nice number visibility wise to use. It gives you the outline of the model, and you can see all the internal parts or porting and holes and such. So there's a lot of holes here. You can see the holes here, they're threaded, and then the internal two ports that we have to drill. How they're at an angle. We can go here, top view, and you can see how they're 30-degree angle here. Here's a drawing that I created, and we have some the set screws, or not the screws that go. I put in here, I listed them. They'll hold the heads on. This is a nice place to put them, and all pertinent information to build this, or machine it, I should say. We have a side view of where the ports are, and an end view. Both ends are the same, so you only need really one end view. And then I did a sectional view here, cutting right through the center, and showing also though these angled ports here, which is kind of nice. And our 30-degree angle and our spacing on the center of the port. Go now to the lathe and start making this thing. All right, I've set the cylinder in here, and it's just loose. It's not, it's just a very tiny bit of play this way, but so it's loose, right? And what we're going to do is we've got the chucking reamer in the chuck. And we're just going to come on down here like this. Now it's going to want to turn, and it should turn against that. We'll just kind of hold it there so it doesn't slam, but it's going to want to turn against that back, the fixed jaw. We're going to put a little WD on here, soak it in there. I'm just going to go nice and easy with it. And it'll just follow that hole. Not trying to make a new hole here. Very much simple as that. And yeah, it's a little hard to see down there, but that's just chips, so it's very nice and clean. All right, I'm going to blow that out. You can see how clean it is now, I think. Yeah, it's stuck in the jaws. There we go. See, this is a 501. Oh yeah, that's a nice. That's perfect. Perfect fit. First a piston type fit, and we're just going to put it in, and it kind of snugs up actually. Then about halfway, it might be a little chip in there, but anyway, that's what I want to do. Just like that, perfect fit. Anyway, so I have it just it's just in here lightly. I just kind of eyeballed it as far as the center goes. There's a parting line on here I used to center it up in between those two jaws, pretty close. And I just kind of eyeballed the center line of the hole with the jaw. So it's kind of close. And I'm just going to use anything here. So I grabbed a tool with a boring bar in it, and as a comparator, and I'm just going to slip my 501 pin in there until it just kind of snugs up. I could probably push that all the way through if I really wanted to. So I'm sticking out here an inch and we'll make it an inch and an eighth. But it's snug. I mean, I can turn it, but it takes a little bit of work. And I'm just going to come up here close, and I have the truck disengaged, so it's easy to turn. And I'm going to see where I'm at. Just eyeballing this here, I can get it real close, real easy. Also, what I'm doing is I'm grabbing a little bit of this front portion of the cylinder, not in the back. I'm more really grabbing the front here because I have my soft jaw inserts in. Now these aren't real thick copper, but I'm not going to grab it super tight. They should protect enough. I'm just going to do this eyeball wise, and then when it looks close, move your tool in a little closer. So I moved in a little closer, and I'll rotate it some more. Because as you move closer, you can tell how far out you are. I'm going to first go in here. Now this is going to be a little bit of an angle, but we're just doing a comparison. We're not trying to measure actually how much run out there is. So if it's at an angle, it'll be okay. I just want it to be on the center line. I don't want it to hit anything like it's doing. I'll come out a little bit farther. There. We're not too bad. Let's see, 15, 20, about 25 thousandths out. Not too bad. I think we're going to leave it there. I'm 1 1/4 or 1 thousandths there. And let's see, I think I'm about 0 here, so needle doesn't move. So we're good. Now we're going to, like I said, we're going to face that and bore it. 3/4 .750 for the bore. Some of the other things you can do is you can turn on and off the parts. Now I'm going to start way down here at the bottom, and I'm just going to turn off all these parts, and you'll see them disappear in the model. We'll go all the way on down. So there's the base. And you can see this is a counter bore for the heads of the 440 screws, the socket head cap screws, clearance. And then here's the tube, the porting, the exhaust and inlet porting, and the bores for the crankshaft. And over here, oops, I forgot to make that surface not the right color. I made these shiny so that they represent that those are machined surfaces. So here we'll just here's the cylinder. We'll put the cylinder on. You can see how that goes in there, and you can see all the screw holes and everything that's in there, and the ports and such. The cylinder head with the stuffing box or the gland is on here, and it's threaded, and counterboard for the packing and such. And the other cylinder head we'll put back on, and you can see where that goes. And then we have the packing that goes in, and now that is now, I turned it on and it's sitting down in here. It's a small, oh, I don't have it centered now. I just noted how that got off center. Anyway, we'll have to straighten that out. I didn't catch that. Sometimes I'm going along pretty quick and I forget what I've done a little bit, so we'll have to center that packing up in the bore. But the packing goes in there, and then your gland nut there. Then we have piston rod will go in like so. Now the piston rod, when I do the piston here, I made this a separate assembly. It's the connecting rod, the bushing, the piston, and the O-ring, and the nut on the end. And then I put that assembly into this model. It's a sub-assembly basically. Now I could also do that with the cylinder, made it a sub-assembly. So here's the crankshaft bushing we'll put in. I forgot to show you the cylinder bushing. Here's there I'll put the bushings back in for for the piston pivot shaft. There's the bushings there, and the bushing there, and the other crankshaft bushing on the other side. So then we have 4 bushings in. Then we have the cylinder mount shaft. We can put that in. There you go, and that's in. What else we have here? We have, and then the crankshaft, I made it a sub. Now the cylinder, back up here, the cylinder shaft is also a sub-assembly because it's made up of 2 pieces. The crankshaft is also a sub-assembly because of the shaft, the flywheel, the set screw, the crank web, the crank pin. They're all sub-assembly. So it was made into a sub-assembly, all those parts, and then just placed into this model. Then we have all the screws. Now what I did here is I inserted the screws. I got them out of the models of the screws out of McMaster. These are the screws holding the shaft here to the cylinder. I got all the screws right out of, I didn't have to draw them. I got them right out of McMaster Car. You can download the modeling of a lot of parts and a lot of hardware from McMaster Car, which is pretty slick. And then you can just place them right into your model. You don't have to draw them or redraw them or anything. Now the spring, so here's one. So this is a spring I downloaded out of McMaster Car. Well, they don't make a spring that is the right length and how easy to put in or anything like that. Instead of dealing with modifying their spring, what I did is I just ended up drawing my own spring. So we'll back up. So here's their spring. It's like 1.5 inches long or something, 1 3/8 inches. Right bore, right wire size, but it's pretty long. I'd have to, you're probably going to end up cutting this if you bought that spring, which is okay. But I have a lot of springs in stock I save, And so I just drew instead. So I just drew my own spring and put it in. And then you have the retaining cups. We'll put in. See, you can just go along and let's see. I think that's all the parts. So that's all the parts to build the engine. Right there. There's some other fun things you can do. Let me see if we'll go here. You can go to animation and in this case here, what I did is I told it to explode the model, and you can animate all this. I haven't played with this a lot, but in here, there, as it explodes the model, and it shows you all the parts. Where roughly where they're located. Some of them are a little bit off for some reason. It's just how it explodes them, and like these 4 screws go clear over here. You know, those 4 screws should have been exploded out of this over here, but you know, whatever it does, that's the computer doing it. But it's kind of cool to see. You can grab your thing and of course put them all back together again. But you can you can make this into quite an elaborate presentation, I should say. But it's kind of cool to be able to see all the parts. A lot of little parts here. And we can just go back here to the model. There we go. And we're going to finish up with the model running away and being able to watch the Gears 2005 engine run before it's even built. Now we're going to go over and go back and now we're going to go and get building on the engine, and we're going to start with the cylinders. So enjoy.